this problem, when you have multiple radicals, you perform the steps for a radical to each time to eliminate one of the radicals. So I'm going to isolate one radical here. I'll do that by adding root x plus 1 to both sides. So I isolate the root 2x plus 3, and then I'm going to undo the radical by squaring both sides here. Squaring this radical leaves just the base 2x plus 3, and this becomes a binomial square expansion pattern. I square the first term, I take the product of the terms and double it. 1 times root x plus 1 doubled is 2 root x plus 1, and then I square my last term. Here the square and the radical cancel, leaving just the base x plus 1. Once I do this, I'm going to solve the resulting equation, which happens to be another radical equation. So I need to isolate this radical as well. So I'm going to subtract an x from both sides. I'm going to subtract a 2 from both sides, and I get is equal to 2 root x plus 1. Again, if I would divide by 2, it would create a fraction, so I'm just going to leave my 2 on the right side. I'm going to undo the radical by squaring both sides. I have a binomial square here. Square the first term, double the product of the terms. X times 1 is 1x, double that is 2x. Square the last term. And here I'm going to square the 2 and square the radical, which just cancels and leaves the base x plus 1. So my result is I distribute my 4 through, give me 4x plus 4. And now I have a quadratic equation with multiple terms containing x. So I'm going to move everything to one side of the equation. So here I'll subtract a 4x from both sides and subtract a 4 from both sides. Give me x squared minus 2x minus 3 equals 0. And so I'm going to check look to factor my expression. The two factors of negative 3, whose sum is negative 2, is negative 3 and positive 1. And so when I solve for this, I get x can be either 3 or negative 1. I want to check each of these and make sure they work back in the original equation. So if I take 2 times 3, which is 6, plus 3, minus, here 3 plus 1 is 4, does that equal 1? Square root of 9 is 3, minus 2 does equal 1, so 3 works. I'm going to test the negative 1. I get 2 times negative 1 is negative 2 plus 3 is 1, minus I get negative 1 plus 1 is 0. Is that equal to 1? So here I get 1 minus 0 does equal 1 as well. So that confirms as a correct answer also.